Okay. So another 2014 constructed response about Albert. Having already read the question, you should have noticed that they gave you a function which tells about the connection between the money collected and the number of baseball programs sold. So this would be like X, okay? And this column would be like the M of X, the money collected. And so again, that function just kind of says that the money collected, the amount of money collected, will be equal to 2.50 times the number of baseball programs sold. So all they want you to do in part A is fill out the table based on the function equation. And again, these are just all X values. So all we have to do is plug in 150 in for X. And on your calculator, you just do 2.5 times 150. So again, this is going to be 2.5 times the X value, and the calculator says that's equal to 375. So $375. And just continuing on the table, now we're going to plug in 175 in for X because that's what X represents. And so we're going to do 2.50 times 175. And the calculator says that that is $437.5. So $437.50. And the final X value to plug in for X is 197. So we do 2.5 times 197, and we get 492.5. And that's all there is to part A. Part B essentially gives you another function, and they just want you to graph it. They're saying on the grid below, draw a line that contains the coordinate points of the cost to print up X programs for each game. Essentially, they're saying draw a line that models or represents that function. So here's one thing you could do. You could set up a table and make a bunch of points where you would plug in 0 to the function, plug in 0 for X, and then C of X would then be equal to 0.50 times 0 plus 40, and so that would be 40. And then you could plug in something like 10. If you plugged in 10 for X and crunched all those numbers together, 0.50 times 10 plus 40, you'd get 45. And then there's other values you could plug in. I guess I skipped plugging in 30 or 50 or there's all kinds of points you could plug in. And then you'd have a bunch of points, like for example, let me just clarify a little bit that this would be 0, 40, for example. And this one would be 20, 50. And all of these points would be on this line you're supposed to draw. That's one way to do it, pretty good way. But you could also see this equation as being in mx plus b form. So this equation is in mx plus b form, where m is the 0.50, and your B value, your B value is equal to 40. Now remember, your B value is your y-intercept. And so I could draw my line by first putting a point at 0.40, or 40 on the y-axis, my y-intercept, which just reinforces that point kind of thing. But anyway, so your B value is 40, and then your M is your rise over run. So you could see this as I'm going to rise 0.5 and run over 1. So it's like you'd go up 0.5 and then to the right 1 to make like another point. But when you look at how this axis, x-axis, is scaled and how the y-axis is sort of scaled and how we're jumping by tens, a rise over run of 0.5 over 1 is kind of hard to draw or represent the way these numbers are. So I hope you understand that going up 0.5 over 1, that could be rescaled to kind of say, well, we could go, that could be the same as going up 5 over 10. Or you could also sort of see it as going up 10 over 20. You know what I mean? So I could start here and perhaps use a slope of up 10 over 20 or up 5 over 10. So I'm going to go up 10 over 20 and put another point. Then I'm going to go up 10 over 20 again and up 10 over 20 again, and maybe one more time. But essentially, my line is going to be right there, passing through all those points. And you could have plotted a point there if you wanted, and a point there. There's all kinds of points you could have plotted, but the sketch of your line needs to look like that. So again, to kind of recap part B, you could have just made a table of a bunch of solutions, which are points, by plugging in certain x values like 10, 20, 30, whatever. Or I guess maybe the quicker way would have been just to see this as mx plus b, where b is your y-intercept and m is the slope of your line. Part C, well, I mean, you should have already read this thoroughly. If not, pause it and read this thoroughly. But they want you to figure out how much money Albert earns as a bonus when he sells 309 baseball programs. But I'm going to emphasize the fact that they say in this one to show all of your work, but also to explain why you did each step. So essentially, Albert's bonus is equal to 1/2 of the difference between the amount of money collected. So this is the amount of money collected, and this is the cost for making all those programs. And they're both based on X, how many programs were sold. And in this case, it's 309. So a quick layout of the strategy would be, well, I guess we have to use the 309 to figure out how much money was collected from this equation, but also the cost by plugging into this equation. And then we're going to need to find the difference between those two amounts, and then find out what half of that is. So it's just a series of steps that you have to, plan out based on reading this thoroughly at least one time, so that you're able to wrap your brain around it, comprehend what you've read, and I guess from there it's just a matter of making sure you write down every single bit of math, showing all your work, but then clearly enough explaining why you did each step. So here's some stuff that I've written down. So this is me showing how I plugged in 309 into the m of x equation. So first I plugged in the number of programs into the m of x function to find the amount of money collected. So this is a pretty good blueprint, I guess, of when you explain things, it's best not to use numbers. You kind of use words and describe units, So notice how I said the words number of programs rather than the number 309. And notice how instead of using the number $772.50, notice how I use the words to find the amount of money collected. So that's a pretty good model for explaining something where you need to explain. Then the next step is plugging in the 309 in for the cost function and then explaining it like so. And then the rest of it would maybe look like this, where now we literally write out the subtraction, and then you explain it by just saying, next I subtracted the cost from the money collected. Notice how I wrote it out all in words and not using numbers. To get the what? What is this? This is the difference. We needed to figure out the difference. So that's why I did this step. And it's just a very simple explanation like this. And then finally you have to multiply, again, writing out all of this, showing everything. As simple as each step is, you have to write it all out when you are supposed to show all your work. And so you write this out, and you show that, and then finally I multiplied 1/2 by the difference to get Albert's bonus of $209. So, because multiplying by 1/2, finds out half.